Hello, and thank you for joining me for the BioFab Middle School Storyline. I'm Lisa Janasek, your guide through this life science unit that addresses performance expectations from LS1, Structure and Function. I hope that you'll be able to take all or part of this unit and make it your own. Please reach out with feedback and suggestions. I look forward to hearing from you. Once again, thank you for being here. Let's dive into this unit. Welcome to the Middle School Life Science Storyline. This unit will support teachers in incorporating the storyline instructional model in the classroom. This project is funded by the BioFab Educational Workforce Development Grant. It was done under the supervision of the University of New Hampshire with Barbara Hopkins as the project director. Through the phenomenon of the axolotl being able to generate damaged limbs, students engage in science and engineering practices to build their elementary understandings of structure and function. In middle school, they'll work from what can be seen, organ systems, to what they cannot see, cells as systems. The unit addresses 3 NGSS performance expectations: LS1-1, LS1-2, and LS1-3. The instructional model used for this unit is the 5 classroom routines based on the work from the Next Gen Storyline project and used by OpenSciEd. This provides student-driven, equitable, high-quality learning experiences for all. We will begin with the anchoring phenomenon routine. The anchoring phenomenon routine is more than a hook. It is a shared experience that drives the learning. It pushes students to represent their initial thinking and to develop questions they have about the anchoring phenomenon. Our anchoring phenomenon is the axolotl can grow back or regenerate damaged limbs. I used a video to introduce the phenomenon. Let's watch.
Welcome to ZSL's Curious Creatures. This week's curious creature is found only in the lake complex of Xochimilco in Mexico. This unusual looking creature is an axolotl, a carnivorous amphibian which can grow up to 30 centimeters in length. Axolotls are unusual because they are neotenic, meaning they keep a tadpole-like appearance for their whole life, complete with feathery gills which allow them to breathe underwater. One of the most curious and amazing features of the axolotl is its ability to regenerate entire limbs that have become damaged or detached in just a couple of months. And despite looking like tadpoles, they are still capable of breeding, with females laying anything from 100 to 1,000 sticky eggs at a time. In the wild, the axolotl has surprisingly few natural predators, however they are extremely vulnerable to changes in water quality. Increasing levels of pollution is the most destructive factor in the survival of this little king of regeneration. Unfortunately, the axolotl is now considered to be a critically endangered species and needs all the help it can get to ensure its survival in the wild.
After viewing the video, students had a discussion and identified related phenomena. All contributions were welcomed and recorded. Next, students tried to make sense. Here they are in small groups making scientific models to explain their initial thinking about how an axolotl can regenerate limbs. This is a formative assessment and will give you a baseline to measure what they understand by the end of the unit. Here are their initial models. From here, we can construct a class consensus model. There are many items that the students agree on and that can be incorporated into a single model. The arrows showing something is happening, the limbs without digits to where they grow back. The Post-its are questions the students generated about the phenomenon while they were collaborating on their models. These questions will help drive the learning experiences, and we will put them on a public classroom document called a driving question board. This is a digital version. You can use a large sheet of paper or a bulletin board. The driving question is on the board. How does the axolotl regenerate its limbs? And all the student questions will be recorded. These are the questions that were generated, and they've been categorized. We've completed the anchoring phenomenon routine. Students were introduced to the phenomenon, our axolotl. They attempted to make sense by drawing initial models. They identified related phenomenon, and they generated questions. The next two routines we'll look at in tandem: the navigation routine and the investigation routine. The storyline is a series of investigations that help students figure out the science concepts that will help them explain the phenomenon. Navigation ties those investigations together, giving meaning to the unit. In the navigation routine, we are always looking back and forward. We look at what we have done, what we are trying to figure out, and what we are doing today. You insert an investigation, and then we look back on what we agree on, what we aren't sure of, and look forward to where we should go next. Each activity has a purpose, and this routine gives them the chance to reflect on their learning over time. Transition points are a great time to use this routine. The investigation routine is repeated throughout the unit as a series of investigations. This is where students engage in science and engineering practices to make sense and develop science ideas to explain the phenomenon. A navigation tool and public classroom document is a summary table or anchor chart. This is a record of what we did and keeps track of the series of investigations and what we have figured out. So where do we start? Let's go back to our driving question board. As the teacher, I know there are a number of questions that won't be addressed in this unit, but they're still important. As time goes on, students will learn how to formulate more specific scientific questions. But for now, a quick Google search of axolotl facts will help move us forward. In a short time, students have the facts they are looking for. We can remove these questions from the DQB and document what we did and what we know on our summary table. Instant gratification, and it frees up their minds for the deeper questions. You have available to you the full axolotl storyline and activity sheets. As shown here, you will find some new activities and some old favorites. They are always framed so students are figuring out science ideas, not proving or repeating what they have been told to be true. The third routine is the putting pieces together routine. This routine is conducted at strategic moments when students need to synthesize ideas from what they have done. This might be at the end of a lesson set and at the end of the unit. There are many types of discussions that will take place during a unit. Here are 3 examples of science discussions. You will see that the putting the pieces together routine is found under both the building understanding and consensus discussions. For more info, please visit Open SciEd Teacher Handbook. The last routine is the problematizing routine. This routine gets the students to think deeper. When students think they have everything figured out, this routine reveals a potential problem with their current model or thinking. It allows students to recognize that there is still more to figure out. In the axolotl storyline, there are examples of students needing to go deeper. The first is applying what they understand to humans. The other is in lesson 15, where they ask about current medical advances that have to do with the regeneration of cells, tissues, and organs, which was the catalyst for this project. There are 8 scientist videos available to you. They range from 7 to 10 minutes in length and introduce you to a diverse group of current scientists working in the biofab industry. In the activity sheets, 3 of the videos are linked. They are a great fit for lesson 15 of the unit. You are welcome to view all of them and use them in your class or careers program. This has been an overview of the BioFab Middle School Life Science storyline with the 5 classroom routines. If you're interested in using the 5 classroom routines, please visit OpenSciEd. They have units and a teacher handbook. Additional resources would be Inquiry Hub Biology and Chemistry, as well as Next Gen Storylines. Again, thank you for attending. I can be contacted at lisajanisic@gmail.com. I wish you well on your NGSS journey.